Hello everyone and welcome to Kaggle's 30 Days of ML, and this is day 5. Today we are going to learn about lists. Day 5 is divided into two parts and I will be uploading another video right after this one. So what are lists? Lists are very useful, and when you're working with machine learning you will end up using it like almost every time. So lists are ordered sequences of values, and to create lists you use the square brackets and separate each element of the list by a comma. So it doesn't matter if you add a comma in the end, it's also fine. So let's say I create a list of prime numbers, 4 prime numbers. So when you print this list, so just writing, primes, so it prints like this. So it's a container containing these values in a sequence. So like if I change the sequence here, if I say 2, 5, let me try again. So I have, let's say I have primes 1, which is a list, and I have primes 2, which is also a list, but here I interchange 3 and 5. So now I have two different lists, and if I want to check, if you remember from booleans, if I do primes equal to primes 2, it's going to say false. So even if they have the same elements, same number of elements and also the same elements inside them, it's not equal. So they are not equal. So sequence matters. Okay, so now we create another list with different planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, no Pluto. And let's run this. So here we have made lists of numbers. And now in this case, we have the list of strings. So we can make a list of any kind of Python objects. And these are all Python objects. So if I do planets, now it's printing me a list of strings. So now let's say we create another list, which is a list of lists. So you can go crazy with this, like let's say list of lists. So inside one list you create another list, and here you have 1, 2, 3, and let's say another list which is A, B, and C, or instead of C you have a list here which is C1, C2, things like this. So you can definitely go crazy with this. So now it prints like this. And here they have shown you list of lists, but every element inside the list of list is a string. So yeah, you don't have to worry too much about it. You can create a list with anything inside it, almost anything. So now the authors creates a list, my favorite things, and the number 32. For me, it will be 42. And raindrops on roses. So, okay, fine. And the help function of Python. So yeah. So now you see, like, you create a list of anything you want. So here you see, instead of writing help, you get this. Okay, so now we come to indexing. So yeah, we always want to index the values which are inside a list. So we have created a list of planets. So let me take this here just for reference. And now if I want to say which is the first planet in this list of planets, I will say planets, and then I will index it with the value 0. So how it goes is this is 0, and then you have 1, then you have 2, and so on. So the list indexing, it starts from 0 instead of 1. So element 0 is the first element of the list. And that's what is shown here. So if I do planets and then inside these square brackets I write 0, I'm going to get Mercury. What is the next closest planet? Venus. So just do planets and 1. Now let's say this list is huge and you don't know how many elements are inside this list. So and if I ask you which is the last planet, so what you're going to do is something very simple. So if we have to find the length of a list, we can do length of planets, which is a list. It's len, and this len function will calculate the length of the list planets. And if I tell you which is the last planet in this list, you can do planets len of planets. Sorry, that will give you length of the list, but the indexing starts from 0, so you have to do -1, and you get Neptune. Now, the interesting thing about lists is you can also index it with negative numbers. So if I do -1, it will give me Neptune. If I do -2, it will give me Uranus. So from the left hand side, it starts with index 0. From the right hand side, it starts with -1. So from the end. And that's what is shown here. So planets -1 is Neptune, planets -2 is Uranus. The third thing, or the next thing here is slicing. So slicing, if I ask you, what are the first 3 planets? So it's Mercury, Venus, and Earth. So what you can do is you can write something like planets, just a colon, and 3. It will give you index 0, 1, and 2. So note, this 3 is not included. 0, 1, and 2. You can also write 0 to 3, which is the same meaning. And if I tell you what are the last 3 planets, so you can do -3 and colon. Last 3 planets. So now it says give me all the planets except the first and the last one. Okay, so you can do from 1 to -1, and -1 is not included. And except the first and the last 2, it's like this. So from Venus to Saturn. And similarly, when you have last 3 planets, last 4, I have already shown you this one before. So you can do -3 and then a colon. Okay, now if you want to change this list, so let's say instead of Earth, I want to change it and say like it's my planet. So here is planets. I can do planets. Earth index is on 0, 1, and 2. I will just write 2 and say my name, let's say. So now when I run this code and I print it, you see Earth has changed itself to Abhishek. And similarly, let's change it again. And you can also change multiple elements at the same time. So here they are changing the first 3 values. So if I change the first 3 values, what do I print? Merv, and then Malacandra here. This was the 4th element. Okay, let's change it back. So here now we should have successfully change it back to the original. Okay, yeah, it is original. Okay, I already told you how many planets are there, so which is the length of the list. If you want to sort the elements of the list in alphabetical order, you can do sorted planets. If you want to calculate the sum, you can get the sum, just write sum. If you want to get max or if you want to get min, you can also do that. So it will give you the max element or the min element. Let's do it like this. Okay. So now I've also been talking about objects since day one, and it might be confusing, but objects is like everything in Python is an object. So that's what you have to remember. And objects have attributes. So these like here, if we are declaring x equal to 12, x is an int, and int has these attributes like imaginary. So like if you can print the imaginary part, and if it's a complex number, the imaginary part is different. So these are called attributes, and function that is attached to an object is called a method. So like here x dot bit length. So here you see it gives you a function. So if you want to call this, you add simple brackets. Yeah, okay, so that's what it's saying here. And yeah, you can also get help for everything in Python using the help function, almost everything. Okay, now let's say if I want to add an element to the list. So if I want to add the planet Pluto back to the list of planets, so I will just do planets dot append, and inside this I can write the element that I want to append. So planets. So now you see we have Pluto. Okay, so that's what append is. So yeah, remember, very important. And now here you can also do list.planets.pop, and pop removes and returns the last element of the list. So if I do planets.pop, I get Pluto, and if I do it again, I get Neptune. So now if I see planets, it doesn't have Neptune and Pluto. So every time you do pop, it will remove it, and it's also going to return you the value. It's going to remove the last element. It's going to return you the value. Okay, one more thing that you can do is, so now let's see that we have removed two values. So I want to add them back. So instead of doing append, what I can do is I can create new list which has Neptune and Pluto. And here I can say planets is planets.extend. So now append is only for one element, but extend is it will extend the list with another list, with a new list. So new planets. And here, let's print this. What we get. Sorry, it doesn't return anything, so it returns none. So this is a mistake I did there. So I don't have to do planets equals, because this function dot extend will return none. So it just adds in place. So I have to run a few things again. So let me go back to the planets, where the planets were. So here, okay, I will just take this and scroll down to the end. So here I have my planets, and then I pop, and it gives me Neptune, and then I pop again, and it gives me Uranus. And here, let's say now I want to add these three. So I do planets.extend, and it will again add Uranus, Neptune, and Pluto. So this is also very useful .extend that you should remember. So searching the list. So if you want to find an element inside a list, you can do planets.index and then write the element, which element you want to find. So if I do Pluto, it's at number 8. And if I do Mercury, it's number 0. So it gives you the exact index. And Earth. So now, instead of writing Earth, I skipped H. And now you see it gives you an error that Earth is not in list. Yeah, okay. So now here, so you got an error. So what you can also do is you can find if an element is in a list or not, and you can do it using something in some list. So Earth and planets, it will give you a boolean, true or false. And like this one, it gives you false because it's not in the list of planets. So now here planets is a list object, and if you run help on planets, it will give you the documentation help on list object. So it has all these information, and if you're learning for the first time, you must go through these. Okay, so now one more thing that I want to show you is, so you have planets, and if you do planets.sort, it doesn't return you anything. So you see it doesn't print any value, it returns none. And now if you do planets again, so you see it has changed the list. So sorted, if you use sorted, it's going to give you a new list. But if you do .sort, it's going to change the list in place. So your list has changed. Okay. So now we move to something else called tuples. And tuples are exactly same as lists. So here you have, there you have square brackets. Here you have normal brackets. The only difference here is that they cannot be modified. So when we were modifying lists, it was simple, like indexing it and assigning a new value, but here you cannot do that. So tuple object does not support item assignment. So this is the error that you will get. Okay, so it says that tuples are often used for functions that return multiple values. So tuples is not just two elements inside, it can have multiple elements. So here this function returns multiple values. So it says, okay, 1 by 8 is 0.125. So it gives you 1 and it gives you 8. And you can then say, okay, my numerator and denominator are the results of this function, and it gives you a tuple of 2 elements. So if I write here now numerator, it is 1, and denominator is 8. And if I add something else, it will give me an error. So it tells me not enough values to unpack. It expects 3 values, but it got only 2. So that's one of the check. And if I have only 1 return, so that will be a tuple. So then you can access tuple using 0 or 1 because it has 2 elements. So swapping 2 variables, we have already seen that if you want to swap, this we saw in exercise. So you can just write a comma b equal to b comma a. Otherwise, you have to create a temporary variable. And that was, I think that was like day 1. Okay, so now we are done and we should move to the coding challenge. Okay, So now the task 1 is to complete the function according to its docstring. So return the second element of given list. If the list has no element, return. If the list has no second element, return none. Okay, so if we try to index something in a list which doesn't exist, it's going to throw an error. So if my list has only 3 elements, so let's say my list has 1, 2, 3, and if I say give me L of 3, it's going to give me an error. So what we have to do here is okay, we have a list L, and I say okay, if my length of my L is more than 1, if I have more than 1 elements in a list, then return L1. Okay, that's the second element. Else return none. But since here it's going to return something and here you just have else, you can also write it like this. Because when it goes inside, when the code goes inside this if part, it's going to return and it's not going to execute this anyways. So now we run it and see, okay, yeah, this is fine. So it can be done in multiple different ways. We can also take a look at their solution. Okay, so they have done like less than. That's completely fine. So now you're analyzing sports team. Members of each team are sorted in a list. The coach is the first name in the list, the captain is the second name, and the other players are listed after that. Okay. These lists are sorted in another list, which starts with the best team and proceeds through the list of the worst team last. Okay. Complete the function below to select the captain of the worst team. So now what it says, there's a list called teams, and inside each team you have a coach. So there is coach 1 and captain 1 and some team members. Okay, so it's like this. You have many lists, let's say 4 for now, and on the top you have the best team. So it says which starts with the best team. So on the top you have the best team, and so the first element of this list teams is the best team, and the last element of the list is the worst team. So let's fetch the worst team first. So worst team will be teams and the last element. So it can be len of the list teams or just -1. And now you have to select worst captain. I shouldn't say that, but anyways, worst team, and that's your second element, and you return worst captain, and that's correct. Another way of doing this is very simple. So you take this, remove this. So teams 1, that's a list, and send me the second element. That's it. Teams -1, 1. So -1 selects the last one, and 1 selects this element of the last one. Okay. So the next iteration of Mario Kart will feature an extra infuriating new item, the purple shell. Okay. When used, it wraps the last place racer into first place and the first place racer into the last place. Okay. Complete the function below to implement the purple shells effect. Okay, so you are given a list of racers. Set the first place racer to the last place and vice versa. So if you remember how we swapped those elements, so let's try this here. So I can say racers 0, comma, racers -1, this equals racers -1, comma, racers 2. Is that correct? Yeah. Or you can do it using a temporary variable, but this is the best way of doing it. So yeah, so here also says this is also a trick. So that's the trick I have shown you: x0, x -1, x -1, x0. But you can also do it like this. Okay, and you see here I didn't have to return racers. The value has changed. So what are the length of the following list? Fill in the variable lengths with your predictions. Try to make a prediction for each list without calling length. Okay, so the first one is very simple. It has 3 elements. So each element of the list is separated by a comma. Okay, so that's what you have to remember. If A is a list, all elements inside A must be separated by comma. So here it should be 3. So now we go to B. If B is a list, each element in a list should be separated by a comma. So this is one element and this is another element. We don't have to go inside this list. This is the second element of the list. So it should be 2. It doesn't have any elements, so it's 0. And here they have a list and they are now indexing that list. So let's do it like this: TMP equal to 1, 2, 3, and this is TMP. So now it's indexing, so it's starting from element 1. So this has 3 elements, but if starting from 1 and going to till the end, it has 2 elements. So the first one is not counted. Okay, so now we have the predictions: 3, 2, 0, 2. Okay. Okay, so this should be temp. Okay. So that's what it says. This list counts as single item. So just remember comma. Okay. So let's see the last one. Is this the last one? Yeah, it is the last one. So we are using lists to record people who attended our party and what order they arrived in. Okay, that's fine because lists have a sequence. For example, the following list represents a party with 7 guests and Adela showed up first and Ford was the last one to arrive. Okay, that's fine. A guest is considered fashionably late if they arrive after at least half of the party's guests. However, they must not be the very last guest. That's taking it too far. In the above example, Mona and Gilbert are the only 2 guests who were fashionably late. So Ford was not. So these 2 were, because they have arrived after half of the party has arrived. Okay, so now given an ordered list of arrivals to the party and a name, return whether the guest with that name was fashionably late. Okay, so arrivals is list of party attendees. So the first thing that we will do is try to find out number of guests, which will be length of arrivals. And now we try to find out the index of the name here. So let's just call it name index. equal to arrivals dot index. So it will tell me where this person is in the list. Name. So now I have number of guests, I have the name index. So now I can say, so this function should return either true or false if the guest is fashionably late or not. Okay. So now I should say, okay, if name index one thing is that you can do directly here is you can say if name is same as arrivals -1, then you return false, because it tells you if it's the last one, then the person is not fashionably late. So if name is same as arrivals -1, the last element of arrivals, you return false. And you have returned this here. So these things don't count. But if not, then these things will run. So now you have name of guest, len of arrival, name index is arrivals.index name. So now you can just say if name index is greater than or equal to more than, so it doesn't say equal to, so name index greater than number of guests divided by 2, return true. Else, we are not using else here, return false. So here you say return false. Okay, so now it says that this is not correct. Okay, so why is it not correct? So we have to go back and see. A guest is fashionably late if they arrive after at least half of the party's guest. So yeah, it should be greater than equal to, and now it's correct. So one thing to remember here is you can also do return here instead of writing if else, because that's also returning you a boolean. So, and this is a boolean which returns same true or false, and that should also be correct. Okay, awesome. Let's see the solution, what they have done. Okay, they have done it like in a very simple way, very less number of lines, but you can do it like this, or you can also like take this thing here and replace here, take this thing here and replace here, and you have similar to them. So yeah, it's a different solution, but yeah, okay, whatever works, right? And this is also correct, this is also correct. Great, so we are done with lists and tuples, and now we are going to learn about loops in the next one. So see you in the next video, and if you like it, do click on the like button, do subscribe, tell your friends about it, do share, and thank you very much.